quadratic functions, we're going to use the knowledge in order to find the function for the cable that sags between the two pylons. And that's what we have right now. So how can we make this work? Let's create a diagram or a graph like we had just before, where we will have our x-axis corresponding to the deck, not the river, the deck level, and the y-axis would be the height of the cable. So both the y-axis is in meters, but also the x-axis is in meters. Let's see. You can see that the center span goes from 0 to 10. Let's suppose that 10 is right here. You can see that the height of the pylon above the river is 5 meters, but we're only going to use the height above the deck, so that is 3 meters. Because remember how the x-axis corresponds to the road, walkway, deck, whatever you want to call it, right? And then the cable sags 2 meters above the deck. That's what it says, at least. Let's have a look. Yeah. The cable sags to a height of 2 meters above the deck. So basically, it's going to drop down here to 2 and then rise again to 10. If we could put there you go. So this number over here is going to be 2 here. And because of the fact that it's 10 meters wide, you understand that it would be right in the middle, and that would be 5, right? So 0, 5, and 10. This is a very good diagram now. Well, not a very good one to put on the project, but it's a very good to understand how we're going to model the function that describes the cable that sags between the two pylons, right? So let's see what we know. Similarly, like before, we know the vertex is going to have coordinates 5 because x is 5 right in the middle of the center span. And the y is 2, that is the height of it. And we also know that when x is 0, the height is 3 meters above the deck. What does that mean? Well, you start again. Y is x minus h squared plus k. Nice and easy. X minus 5 squared plus 2. We made use of this piece of information. Now let's go to the next one. When x is 0, y is 3. 3 is a times 0 minus 5 squared plus 2. 3 is 25a. See, you have multiplication, so this operation must come first, and you leave the plus 2 later on. Plus 2. Now you subtract 2 from both sides, so that becomes 1 equals 25a. And at the end of the day, your a is 1 divided by 25. Oops. Now, summarizing your results, that would give you that a is 1 over 25. Whoopsie, that doesn't look very good. 1 over 25, x minus 5 squared plus 2. That is the function that describes the cable here. But let's see how it looks. So you open your Desmos, and you're going to have to enter it there. So y equals 1 divided by 25. Oops. Divided by 25. And say times bracket x minus 5 squared plus 2. And let's have a full picture here. That's how it's going to look like. And now you're going to have to enter this graph in your project. So let's give it a good range. So x, first of all, it can only take positive values. It represents length. from 0, and let's put it to 12 meters, just so we can have a full picture. Now the y-axis, let's have it also from 0, that represents the height. Or if you want to put it above the river, just so you can have an idea, the river was at -2. I think it was 2 below. I don't remember. Let's put it from 0. That's okay. From 0, and let's put it to 5 meters maybe. Yeah, that's it. Yeah, and that is how it's going to look like. Now, if you want to restrict your x, so your graph doesn't extend that way and this way, of course, you can also do it here on Desmos. So you go, after you have entered your function, you can go and put those curly brackets and say, well, my x, I want it to be from 0 to 10. Actually, there you go. Now you have restricted the values of x. So now you have shown exactly how your bridge looks like. Whatever you have written for x that goes from 0 to 10, that is also your domain. So if you take this as it is, if you could copy, that'd be great, but you can't. And you go back to your Word document, for example. When you write your project, you're going to have to state the function that you found, which was this. But also, this function, it is for the domain. What's the domain? Is x such that 0 is less or equal than x, which is less or equal to 10. Just so you can give the domain of the function that you just found. So you would have to report your way of finding it, the method, the final answer that you have, and the domain, together with the graph that you get from Desmos. And that was the answer to part